In this video, we are going to learn about the angle bisector proportionality theorem. Specifically, we are going to illustrate the angle bisector proportionality theorem and apply this theorem in solving the unknown sides of a triangle. So let's look at the theorem. An angle bisector in a triangle separates the opposite side into segments that have the same ratio as the two other sides. Suppose we have here triangle ABC and angle ACB is bisected by segment CD as shown in the figure. Therefore, we can call CD as the angle bisector. And that angle bisector CD divides the opposite side AB into two parts. So you have here AD and DB. Now by the ABPT, we can say that the following proportions hold. AC over CB is equal to the ratio of AD over DB. If we rewrite this equation, we can also say that AC over AD is equal to CB over DB. To generalize these two proportions, we can use the following naming conventions or legends. So, using this figure as our guide, let BC is equal to A, AC is equal to B, BD is equal to M, and DA is equal to N. So, in this triangle BCA, angle BCA is bisected by segment CD. So therefore, CD is an angle bisector. And CD divides side BA into two parts. You have here BD and DA, which are represented by the variables M and N respectively. So by the ABPT, the following proportions hold. Number 1, A over B is equal to M over N. And the other proportion, A over M, is equal to B all over N. Now, let's look at some exercises. So, based on the given figure, let's determine which of these following proportions are correct. Okay, so we have here again triangle BAD, wherein angle BAD is bisected by segment AE. So, AE divides segment BD into two parts, and those two parts are BE and ED. So let's determine which of these proportions hold true using the ABPT or the angle bisector proportionality theorem. So let's start with the first one. DA, so this is DA, over DE is equal to AB over EB. And this proportion is correct. So it is true. Number 2, BA over ED. So as you notice, so hindi na sila magka-adjacent na segments. Therefore, number 2 is not correct. Number 3, let's try number 3. You have BA over BE that is equal to EA over ED. So as you notice, there is a wrong side here, EA. So instead of EA, this should be AD. So number 3 is also incorrect. For number 4, DA, so this is DA over AB, okay, is equal to DE over EB. And this is a correct proportion. So if you arrange equation 1, you can come up with equation 2, and they are both correct as well. And lastly, for number 5, dB, so this is dB, the whole of this, over dA is equal to AE over EB. So the sides are wrong, or the proportion is incorrect. So number 5 is false. Okay. So how about for this problem? Let's say given a triangle with the following measurements, and we have an unknown segment here, which is represented by variable x, and we want to get the perimeter of the triangle. So to solve for the perimeter, so perimeter is just the sum of the 3 sides of the given triangle. So what are these 3 sides? So for side 1, we have 18. For side 2, we have 12. And for the third side, so the length should be the sum of x and 6. So S3 is equal to x plus 6. So if we want to get the perimeter, so perimeter equals 18 plus 12 plus x plus 6. Or to simplify this is 18 plus 18, so that is 36 plus x. So to get the value of the perimeter, we need to find x first. Okay, so to find x, we can use the ABPT. Okay, and our equation would be 18 over x is equal to 12 over 6. So performing our cross multiplication on this, so 18 times 6 over 12 is equal to x. Therefore, x is equal to 9. So if x equals 9, therefore the perimeter is equal to 36 plus 9, or that is 45 units. Another similar problem. So in order to get the perimeter, you need to get the sum of the 3 sides. That is x plus 7 plus 10 plus 6 plus x. Simplifying this, you have 7 plus 10 plus 6, you have 23. X plus x is 2x. So to get the perimeter, we need first to find the value of x. By ABPT, our working equation would be x plus 7 over 6 equals 10 over x. Cross multiplying, you get x times x plus 7, so that is x squared plus 7x equals 6 times 10, that is 60. So I have here a quadratic equation, x squared plus 7x minus 60 is equal to 0. Can we factor this out? Let's try. So get the binomial factors. Factor x squared, that is x and x. And for 60, so you have 12 times 5. So to get 7, that is positive 12 minus 5. Okay, so we have two values of x here. X can either be negative 12 or x is equal to positive 5. So since we are talking about length of segments, we should take the positive value of x. So we reject negative 12 because the value of x in this triangle cannot be negative. Okay? So x equals 5, therefore the perimeter is 23 plus 2 times 5, which is equal to 33 units.